Nalibnos kinaindaklan nga aldaw kaadal, adtoy ni Maestrong Eliocano, amang iturong kada kayo ti pagsayaatan, pagbanagan ken pagdurasan ti siyensya. Come and join me as we explore the wonders of science.
A solution is an example of a homogeneous mixture. It has two components, the solute and the solvent. The solute is the component that dissolves in the solution or the component that comes in lesser amount than the other component, whereas the solvent is the dissolving medium or the component that comes in greater quantity. Most solutions in nature contain more than one solute. These solutions are called complex solutions. Solutions are formed when a solute is added to a solvent. During the dissolution process, the chemical bonds that hold together the particles of the solute are broken. This allows the particles of the solute to slide in between the particles of a solvent. A solution may be classified as a solid, liquid, or gaseous solution. These classifications depend on the nature of the solvent. If a solid or liquid solute is dissolved in a solid solvent, then the solution is classified as a solid solution. You have already learned a specific type of solid solution called an alloy. Small, solid particles are placed in molten metal. An example of this is carbon in molten iron. As the iron cools, the solid carbon particles remain dissolved in the solidified metal. The end product of this process is called steel. The same process is employed in making various alloys such as brass, bronze, and solder. For liquid solutions, the most common solvent is water. Water can dissolve more solid substances than any other liquid solvent. This property of water is the reason water is also known as the universal solvent. A liquid solvent can dissolve either solid solutes, like salt or sugar in water, or gases, like carbon dioxide in water, to form carbonated or sparkling water. Because of their properties, gases mix with other gases easily. Gas molecules are far apart from one another, allowing other particles to slide in between the spaces. For example, oxygen gas and carbon dioxide gas can easily be mixed in container to form a gaseous solution. The gas in larger amount will be the solvent, and the gas in smaller amount will be the solute. Air is another example of a gaseous solution. It is a homogeneous mixture of different gases. However, because of pollution, there are solid particles suspended in air as well. Let's talk about solubility. Solubility describes whether a certain solute can be dissolved in a specific solvent. Specifically, it refers to the maximum amount of solute that can be dissolved in a certain amount of solvent at a fixed temperature. For example, 36 grams of salt can be dissolved in 100 grams of water at 20 degrees Celsius. This means that if you place 36.5 grams of salt in 100 grams of water at 20 degrees Celsius, only 36 grams will dissolve, and the remaining 0.5 grams will be deposited at the bottom of the container. The term solubility can also pertain to a quantitative ability of certain solutes, like solids in general, to dissolve in solvents, which are usually liquids, at a certain condition. For example, salt and sugar are considered very soluble in water at high temperatures, but slightly or moderately soluble at lower temperatures. Chalk or calcium carbonate is insoluble in water. What are the factors affecting the solubility? First is the temperature. Another one is pressure. Let's talk about the rate of dissolution. Dissolution is the process in which solutes mix with the solvent to form solutions. The rate of dissolution is different from solubility. The rate of dissolution describes how fast a certain solute dissolves in a solvent, whereas solubility describes how much solute can be dissolved at a given solvent for a specified temperature. Certain parameters can either speed up or slow down the dissolution. Here are some of the factors affecting the rate of dissolution. First, we have temperature. Another factor is the particle size or surface area in contact. Another factor is the agitation. Another factor is the amount of solute or concentration of the solution. Let's talk about the concentration of solutions. The concentration of solution refers to the amount of solute dissolved in a given solution or solvent. Concentration of solution can be described quantitatively or qualitatively. The following are some of the qualitative descriptions of concentrations. Number 1. Diluted solution and concentrated solution. Diluted solution refer to solution with very small amounts of solute dissolved in it, whereas concentrated solution refers to the solution containing larger amounts of dissolved solute. The term diluted and concentrated are highly subjective as they do not completely describe the amount of solute dissolved in the solution or solvent. Dissolving the teaspoon or juice powder of solvent will produce a diluted solution. However, if you placed 1 teaspoon of powder in a small glass of water, you will produce a concentrated solution. Number 2. Saturated, unsaturated, and supersaturated solutions. You have already identified that only 36.0 gram of salt can be dissolved in 100.0 gram of water at 20 degrees Celsius. If you add 37 grams of salt in 100 grams of water at 20 degrees Celsius, only 36 grams of salt will be dissolved and the remaining 1 gram will settle at the bottom. This solution is called a saturated solution. A solution becomes saturated when the solvent has already dissolved the maximum amount of solute that it can dissolve. A saturated solution cannot dissolve more solute without changing certain conditions such as the temperature and the solvent or pressure. An unsaturated solution contains lesser amount of solute than a saturated solution. A solution containing 100 gram of water and 30 gram of salt at 20 degrees Celsius is an unsaturated solution. Unsaturated solutions can still dissolve solid solutes until it reaches saturation. Most of the chemical solutions that you are using in the laboratory are examples of unsaturated solutions. A solution that contains more than the expected maximum amount of solute is called a supersaturated solution. A supersaturated solution can be prepared by heating a saturated solution that contains undissolved solids. The increase in temperature will cause these solids to dissolve. The temperature of the solution will be lowered gradually to minimize the reformation of the dissolved solutes back to its solid form. The particles of a solute in a supersaturated solution are so close together that a slight disturbance can cause these particles to move together and form crystals. This process is called crystallization. Examples of these disturbances that can cause a formation of crystals or precipitates are jarring, stirring, dropping acid crystals, and moving the solution.